This is video 4 of Unit 14, and here we'll continue talking about pH and how it relates to mathematically measuring the acidity or the basicity of a solution. So here is the question. We've defined pH in the previous video. Here we're going to go backwards, undo it. What if we were given the pH and we're asked to find the concentration of the hydrogen? And this is actually pretty important, because what if you have a solution? We have a special probe called a pH probe that you connect to a machine, and it shows you the pH of your solution. So you can actually measure the pH of your solution, and from there you can find out, you should be able to convert then to the H plus concentration. In other words, find out how much acid you have in it, and this tells you, the molarity of your acid, for example. And this is what we're doing this for. So if you undo the pH equation, remember the pH equation looks like this, negative log of H plus. This was the pH equation. Now if you undo it, rearrange, and I won't show you this here, but if you would like to see it, we can show it to you. If you rearrange it, here's what you get. The H plus concentration equals 10 to the negative pH. And this kind of shows you where the power comes from, the power of hydrogen. Here it's the power of hydrogen. But it has to be negative, essentially. This number has to be negative. And there's a few reasons for that. Actually, the reason for it is because this is negative, and because when you take the pH of small numbers, you get a negative number. So we didn't want to deal with negative pHs, so we stuck that negative to get rid of the negative. If that doesn't make sense, don't worry, just simply use this equation. And let's go ahead and apply it and see what we can do with it. So here's the equation. What is the H plus in a solution with a pOH of 12.4? So we have a solution, the pOH of 12.4. We're asking how much hydrogen, how much acidity is in there. We have to use a few equations. The first equation then is the one that relates pOH to pH. Remember, we said last time that pH and pOH is equal to 14. So you can take 14 minus pOH to give you pH, because you just simply subtract the pOH on that side. Okay, so 14 minus pOH is 14 minus 12.4, which is 1.6. This is now the pH. And if we want to know the H plus concentration, H plus concentration, remember brackets mean molarity, is 10 to the negative pH, which is 1.6. Go ahead and still put this in your calculator. You may have to find a button that does 10 to the power, or you can simply do, if you will have a y to the x button or an x to the y button, try that. So do 10 raised to the power of 1.6 negative, and that should give you 0.0251. 0.0251. This does have a unit on it. This will be molarity, because we're solving for concentration. So simple as that. So we're essentially going backwards. So this allows you to be able to measure the pH of a solution and then find out the concentration. You could also do the same thing and find out the concentration of base. In other words, what you could do is the OH minus concentration is equal to 10 to the negative pOH. You could get the hydroxide ion concentration if you have a base. So for a base, the equation is really the same. Just keep track of your pHs and pOHs. Okay, we're going to finish up with a discussion of something called a titration. Now, this is kind of a complex idea, but we'd like to introduce it to you here, and then we'll maybe go with it further later. And a titration is a laboratory technique where a known base is used to react with an unknown acid and find its concentration. So this is just a lab technique that allows you to react two chemicals and use one chemical to find out about the other chemical. Now what you have here is, this is a regular flask, and you put the unknown concentration in the flask. In this case, we can put the acid in here, your unknown acid, and then you have a special device called a burette. And this essentially is a long tube that's graduated that has these markings that you can read how much water you're adding to it. And you put your known concentration in the burette, and you're able to measure exactly how much you're adding. And there's a special little valve that opens up and this drops in. So what you do is you drop by drop, you react the acid with the base. And by measuring how much base it took to react with the acid, you can find out how much acid was in the solution. So you can find out the unknown becomes unknown. And we're going to do an example of this for you. So here is an important concept before we do this. And the concept is the equivalence point. The equivalence point is when all the acid has been neutralized by the base. So this is essentially when the base, OH, has combined with acid, H+, to produce water. So you have essentially reacted all the acid with all the base, and this is where you stop your reaction, because you can't just keep adding the base and adding. You have to stop. And the way we know when to stop is we would use an indicator. We discussed indicators before. This is actually a very important application of indicators. Very often the famous phenolphthalein indicator is used. So at the equivalence point, the moles of acid will equal the moles of base, and you stop the titration. So let's see if we can wrap our heads around this problem. In a titration experiment, it takes 35 milliliters of 0.10 molar sodium hydroxide solution to neutralize 42 milliliters of HCl. What is the acid concentration? So what we'll do is we'll realize that at the equivalence point, moles of acid equals moles of base. So what we need to find is moles of base. Here's our base. Here's the molarity. Here's the milliliters. We have to find the moles of base, and then we'll use that to find the concentration of the acid. So here's your base. To find the moles, remember, if you rearrange the equation for molarity is moles over liters. If you rearrange it to solve for moles, you get yourself liters times molarity. In this case, my liters is 35 milliliters. So to convert this into liters, remember, we divide by 1,000. So we got ourselves 0.035 liters. Then you would multiply that by our base, 0.10, and you get yourself 0.0035 moles. This is a base. So what I did is, because my equivalence point essentially comes down to this, the moles of base equals the moles of acid. So I first found the moles of base. We've got that. This was the moles of base that was added to the acid. And now the amount of acid then, here we have acid, you can do it in red. The amount of acid is now the same as the moles of base. So the amount of acid is 0.0035 moles. And what we'll have to do now is find the concentration. Well, concentration is simply molarity. Molarity, again, is moles per liter. So your moles is 0.0035. Your liters is a good question. The 42 milliliters of HCl would be the liters, except we would have to divide by 1,000 again to get to liters, so this would be 0.042 liters. And if it helps, you can make a little bit of a note that we converted this from 42 mils. Okay, so if you divide these two numbers, you actually get your answer, 0.0035 over 0.042, which gets you 0.083 molar. And here it is. Now this is actually a pretty neat little experiment. You began essentially with a little flask of acid, and you didn't know what the acid concentration was. And you added to that a base. You added a known amount of base to it, neutralized it, and you found the unknown acid concentration. So you could do this sort of thing with acids and bases. You can actually use this technique with many other reactions. As long as you know the relationship between the two reactants, you can do this technique. So try to do a few of these on your own, and we will see you in class.